Aside from being on average the farthest planet from the Sun, Pluto and its orbit have several characteristics that make it unique. Its greater distance means its orbital period of 248 years is the longest of all planets. Its orbit has the highest eccentricity, which means that its distance from the Sun varies more than other planets. Its orbit is so far from circular that it can actually be closer to the Sun than Neptune at times. The plane of Pluto's orbit is also tilted the most compared to the rest, taking it further north and south of the Earth's orbital plane than the other planets. Pluto's only known satellite, Charon, is the largest satellite compared to the size of its mother planet. The Earth's moon held that title until Charon was discovered in 1978. Charon's large mass relative to Pluto means that the center of their common orbit about each other lies outside Pluto's surface, another unique characteristic of this planet. Finally, Pluto itself is unique for its position and physical characteristics. The four inner planets, Mercury, Venus, Earth, and Mars, are known as terrestrial planets for their smaller size, solid surface, and similarity to Earth. The next four planets, looking outward from the Sun, are gas giants. They are larger than the terrestrial planets, have a larger number of satellites, and no solid surface. Beyond the gas giants, Pluto breaks the pattern by once again showing characteristics more like a terrestrial planet: small, solid surface, and only one known satellite. Is there any other possible way for Pluto to have a water ocean under its heart-shaped Sputnik-Planitia glacier, which is so well known worldwide? It's not just a frozen pond we are talking about here. It is a nitrogen glacier of about 1 million square miles. According to the scientists, there is a whole bunch of frozen nitrogen on top of that lake, and under it, there is a big ocean of liquid water free to flow. It tells that Pluto's history goes to 2,000 years, but it is closer to 4 billion years, and as a result, it has so far surpassed all the expectations. Alan Stern, a New Horizons mission chief investigator, however, is hopeful that such a discovery could solve the mystery and be a glimpse of the fact that life might exist in some unexpected yet suitable spots of the universe. When scientists first examined the detailed images of Pluto from the New Horizons mission, they were astonished. A distant world, once dismissed as a cold, lifeless rock, showed signs of geological activity that upended everything we thought we knew about the outer reaches of our solar system. Declassified data from cutting-edge telescopes like James Webb has added even more intrigue, hinting at extraordinary possibilities beneath Pluto's icy shell. Could this frozen dwarf planet hold the key to discovering alien life? Pluto's iconic heart-shaped glacier, Sputnik-Planitia, might be more than just a visual marvel. This massive nitrogen glacier spans over 1 million square miles, and beneath its frozen surface, scientists suspect there could be a vast reservoir of liquid water. If true, this means Pluto has maintained this hidden ocean for billions of years, challenging long-standing assumptions about where life could potentially exist in our solar system. Convection patterns in Sputnik. Planitia's ice further reveal Pluto's unexpected activity. The surface, surprisingly smooth and devoid of craters, churns slowly like a giant lava lamp. This phenomenon, driven by heat from radioactive decay in Pluto's core, could explain how the ocean beneath remains liquid despite the planet's frigid conditions. Even more puzzling is Pluto's dynamic geology. Vast mountain ranges made of solid water ice soar up to 4 miles high. Cracks and faults crisscross the surface, hinting at the planet's crust flexing and shifting, likely due to a subsurface ocean. The glacier's massive weight has also caused Pluto to reorient itself, aligning with the gravitational pull of its largest moon, Charon. This delicate gravitational dance points to a far more complex and interactive planetary system than anyone had anticipated. The possibility of liquid water raises the tantalizing question: could there be life on Pluto? Renowned physicist Brian Cox speculates that even microbial life in such an environment would be groundbreaking. Insulated by a thick layer of ice, a subsurface ocean could protect potential life forms from cosmic radiation and extreme temperatures. While the idea of thriving organisms remains speculative, even the simplest microbes would revolutionize our understanding of life's resilience. New Horizons offered a fleeting glimpse of Pluto, imaging only about 40% of its surface. The rest remains shrouded in mystery, awaiting future missions like the proposed Pluto orbiter. Such a mission could provide the detailed data needed to confirm the existence of a subsurface ocean and explore its implications for extraterrestrial life. However, the immense distance and technological challenges make this endeavor a daunting one, likely taking decades and billions of dollars to achieve. If Pluto, located billions of miles from the Sun, can host a liquid ocean, it redefines the traditional boundaries of the habitable zone, the region around a star where conditions might support life. This discovery forces scientists to reconsider the potential for life on other icy worlds, such as Europa and Enceladus, moons of Jupiter and Saturn that also harbor subsurface oceans. Recent studies suggest Pluto may have formed in a violent, heat-generating process that left it with a liquid ocean. This ocean, sustained by radioactive decay, could have persisted for billions of years, potentially long enough for life to emerge. If Pluto's ocean exists, it raises questions about other distant worlds in the Kuiper Belt, like Eris and Makemake, and whether they too might conceal hidden oceans. Scientists have discovered carbon dioxide and hydrogen peroxide on the surface of Charon, Pluto's largest moon, offering clues about the origins of the space rock and other celestial objects in the distant solar system. Using observations from the James Webb Space Telescope's near-infrared spectrograph instrument, astronomers at the Southwest Research Institute in Boulder, Colorado, gathered new details about Charon's composition. Previous exploration at NASA brought basic information to light about the icy mass, including the fact that it was composed mainly of crystalline water ice, ammonia, and several other organic materials. The latest findings are significant as they highlight insights into the chemical diversity and evolutionary processes on Charon, wrote the team of researchers at SWRI in the results of their study. Those results were published Tuesday in the journal Nature Communications. Technically the largest of Pluto's 5 moons, Charon is actually half the size of its parent planet at about 754 miles wide. The relationship between their relatively similar sizes is unusual, according to NASA, so Pluto and Charon together are sometimes referred to as a double dwarf planet system. The New Horizons spacecraft has studied the distant moon before, collecting images of Charon in 2015 as it approached a point in its orbit nearest Pluto. Those images revealed a vast tectonic belt stretched across the equator, hinting at a water ice ocean present long ago, and notably a red-toned region at the massive moon's northern pole. The discovery of an ocean on Pluto is about more than just this one distant world. It's a paradigm shift in how we understand our solar system and the conditions required for life. As scientists continue to analyze the data and plan future missions, Pluto serves as a reminder that the most unexpected places often hold the biggest surprises. Could this icy dwarf planet's hidden ocean mean life exists in places we never imagined? Or does it point to even darker, more mysterious phenomena lurking in the cosmos? One thing is certain, Pluto's story is far from over. Learning more about the composition of Pluto's moon could potentially provide insight into Charon's neighbors in the Kuiper Belt, the researchers said. The belt region encompasses the other rings of the solar system, beyond Neptune's orbit, and is home to icy objects like dwarf planets as well as some comets. The ability to identify compounds like carbon dioxide and hydrogen peroxide on the frigid surface of Charon could be valuable for scientists to understand how fundamental processes, radiation exposure from the sun, for example, or cratering caused by impacts over time, work in this faraway place. Understanding that could in turn help explain how the objects in the Kuiper Belt came to be. It could even shed light on questions about the beginnings of solar system. Beyond Neptune, a fascinating collection of small bodies known as trans-Neptunian objects, TNOS, orbits the Sun. These objects serve as time capsules, offering scientists a glimpse into the early solar system. Sylvia Protopapa, the lead researcher on the study, told CBS News. They are characterized by unique surface compositions, physical properties, and dynamical characteristics that hold clues to the solar system's origins. More research needs to be done to determine which compounds on the surface of objects like Charon are pristine and which have been modified over time by external factors, Protopapa added, noting that all those variables can change the mass's original state.